So we're going to start looking at inverse trig. We've already kind of used some aspects of inverse trig, and now we're going to go into it in a lot more detail. So again, we are still going to be using that unit circle, and there is an image of it there. If you need to refresh yourself on that, I would recommend you do so. We're going to be using the unit circle again for the next few weeks, okay? So make sure you still have that. Go through it again if you need to kind of refresh yourself on it, and otherwise the next few weeks are going to be a little bit tougher, okay? So inverses. For a function to have an inverse, the function has to be 1-to-1. And what it means to be 1-to-1 is that we have a unique y for every x. And if you remember, the way we check to see if the inverse is a function is by doing the horizontal line test. So below is a graph of sine, right? And we're trying to figure out, is it 1-to-1? Does it have an inverse? So as it currently sits, if I do the horizontal line test, this thing fails. It hits my graph a bunch, right? It can only hit once when I do the horizontal line test. So this is not 1-to-1, and that causes us some issues. So the way we handle that with trig, since the whole function is not 1-to-1, we have to apply a restriction to y equals sine of x. And the restriction we're going to use for the domain is from -pi/2 to pi/2. And there's kind of a blown up image of what that looks like on the graph of y equals sine of x, just to show it here. Right, here is -pi/2. Here is pi/2. So we're restricting my sine graph to just this section of it, okay? And the range is still the same, right? -1-to-1. Now, inverses reflect across the line y equals x. So here is y equals x, right? That's just a straight line, slope of 1 going through the origin. And if I think about that little segment, right, of sine, that is right here. And then my curve would continue normally, right? Graphing the inverse, right, we reflect across that green line there, y equals x, and I would have the same sine shape. It would just be going up the y-axis, and this would continue this way. Okay. So the domain of sine, so this is the sine, right? And remember, with inverses, we switch x and y. So we switch the domain and range from f to f to the -1, right? So the domain of f becomes the range of f to the -1, which would be the inverse. And the range, -1-to-1, becomes the domain of the inverse. Now, the way we represent inverses for trig, we've kind of looked at this already, right? Sine to the -1 of x. And, you know, here's like the math way of finding inverses. If you remember back to our functions unit, remember we switch x and y, and then we resolve for y. So if you think back to the triangle trig unit, to get rid of this sine, I would do the inverse of both sides. So that makes that kind of go away, and then we're left with this guy, okay? And that's what we've kind of looked at already. Another way that they represent inverse trig is with the word arc in front. So arc sine, arc cosine, arc cosecant. Okay, just know that arc is describing that we're, hey, looking at the inverse, okay? So, inverse trig, it's kind of going in the opposite direction of what we normally think about when we're evaluating trig. So if I think about a normal trig problem here, and we do the sine of pi over 4 equals the square root of 2 over 2, right? The y value at the point after I rotate pi over 4 radians. Now, the inverse, we kind of go in the opposite direction. So we start with the square root of 2 over 2, and then we identify, well, what angle measure goes with that ratio, right? So the inverse, we would get a problem like this. And that would be pi over 4. So for inverse trig, we're putting in our ratios from the unit circle, right? My x value or my y value, and we're finding my angles, okay, those radian measures. So for sine, okay, since we're restricting ourselves to negative pi over 2 to pi over 2, we only have specific answers that we can get. And if I look at my unit circle, here would be to pi over 2, right? So there's pi over 2. And then here would be negative pi over 2. So when I'm dealing with inverse sine, I only care about this half of my unit circle. Okay, these are the only answer choices I can get. So things from quadrant 1 or quadrant 4. Okay. And this kind of goes with, if you think back to the triangle trig unit, this is why we can't really use inverse sine to find those oblique angles, right? Because inverse sine doesn't give me answers that are over here for my bigger angles, right? I'm stuck in quadrant 1, I'm stuck in quadrant 4, okay? So, thought process. First thing we got to think about, look at the ratio given to you. Is it on the unit circle? No, we're going to talk about that later. Okay, that's an issue that we'll talk about eventually. It is on the unit circle. Okay, we want to figure out, well, what quadrant is it in? So I want to look at the sine of the ratio, right? Is it positive? Quadrant 1 for sine. Is it negative? Quadrant 4 for sine. Then we want to find that value on my unit circle and then find the radian measure that goes with that angle of rotation. And that's my answer, okay? So let's look at some answers here. Again, the way I kind of always do these problems in this unit is I always draw my two halves, or my half circle, so I know that, okay, sine is this. And as we go through the rest of the trig functions, they all kind of are grouped into two different categories. And we'll kind of talk about that more as we get into the different trig functions, okay? So, sine inverse of the square root of 3 over 2. So this thing is positive, right? So positive y's, that puts me in quadrant 1. So I find that the square root of 3 over 2 for my y value happens right here. So that means my answer would be pi over 3. Okay. Now eventually, right, as we get back into using the unit circle, get familiar with it again, we're going to kind of be able to do that just by recognizing the x and the y values that are given. Looking at the next one, I have negative, right? So negative y would happen in quadrant 4. Negative square root of 3 over 2, right here. And that's at 5 pi thirds. Sine of 1 is the quadrantal, right? That's right here. And that's allowed, right? Because we had closed brackets. We went from negative pi over 2 to pi over 2. So pi over 2 is included, and that is a possible answer choice. This last one, square root of 2 is not on my unit circle, and we'll talk about that guy a little bit later, right? So that is sine. Let's look at cosine. So there's my cosine graph. Again, not one-to-one, right? So I need to restrict my domain. And again, when I restrict it, right, I'm just looking at a particular section, and we're going to restrict the domain from 0 to pi. So that gives me this part of my cosine graph, okay, which is blown up here, right? So if I think about, here's my y equals x line, right? And here is cosine. If I reflect that across that line, y equals x, that gives me this guy. Okay, and again, domain flips, so this would be for cosine, and this would be for the inverse. Now, we have to kind of talk about, well, where does that happen, right? I'm looking at 0 to pi. So here's 0, here's pi, right? Because remember, I'm restricting myself 0 to pi. So here would be my largest possible rotation. So my answers for inverse cosine is the top half of my unit circle, quadrant 1, quadrant 2. This is why we used the law of cosines to find the biggest angle, those obtuse angles of my triangle, because I can get these larger angles of rotation, right? That's possible now with inverse cosine. So, same process, right? I'm given the ratio. I'm going to find where that is on my unit circle and describe what angle measure that's taking place at. So looking at this, I want to check my sine. It's positive, so that means I'm in quadrant 1. Cosine of 1/2, that would give me pi over 3 radians. Negative square root of 3 over 2, that happens right here. 5 pi over 6, right? Negative, sorry, and that means it's in quadrant 2. -1 is that quadrantal angle, right here. And again, because of the closed brackets, I'm allowed to have pi as an answer. And again, square root of 2, not really helpful with the unit circle. This is kind of where we would need to use my calculator. And we'll talk kind of more about that when we get into solving, okay? But ultimately what I would do, we'll get into that later. All right, last one real quick. Tangent, right? Again, these things are not one-to-one because they're periodic, right? They keep repeating themselves. And because of that, the horizontal line test will always fail. So restricting my domain, we go from negative pi over 2 to pi over 2. Now, it's important to note the difference here. We have parentheses, which means negative pi over 2 and pi over 2 are not possible answer choices. And again, that's because of my asymptotes, right? So, again, flipping things around, y equals x. So instead of that being my vertical tangent graph, right? If I flip it, it's going to be horizontal now. So this would be my inverse. Okay. And in class, I'll show you a Desmos thing where it kind of builds the inverse off of the regular, so you can kind of see what's actually happening. So we'll talk a little bit more about that in class. Now, for tangent, again, we're going pi over 2, negative pi over 2 to pi over 2. So I'm stuck in quadrant 1 and 4, similarly to sine. Okay. And before we do tangent, let's go ahead and find all of my tangents for my possible angle measures. So this is the square root of 3 over 2 comma 1/2. Got a little cutoff here, negative 1/2. So the tangent of 0 or 2 pi, right? So think about what tangent is. Sine of x over cosine of x. So y over x. If the y value is 1 and the x value is 0, that's when it's undefined. So that means we can't have values here or here. So let's start at 0. This would be 1 comma 0. So 0 on top, 1 on the bottom. That would give me 0 for my tangent. 1/2 over the square root of 3 over 2. Doing some of that math, we would get the square root of 3 over 3. Square root of 2 over 2 over square root of 2 over 2 would give me 1. And then the square root of 3 over 2 over 1/2 would leave me with the square root of 3. So in quadrant 4, so that's quadrant 1, we'll get the same values. It's just they're going to be negative. So pi over 6 and 11 pi over 6 are similar. It's just 1 is going to be negative now down here. This would be negative 1, and this would be negative root 3. So I'm given my ratios here. This thing is positive, so I'm looking quadrant 1. Square root of 3 goes with pi over 3. Negative, quadrant 4. That's located right here. So that would be 11 pi over 6. And then negative 1, so negative again, quadrant 4. That's going to be one of my pi over 4s. And the pi over 4 in quadrant 4 is 7 pi over 4.